Okay, this one caused a few bits of problems. It's very easy. One of the difficulties you have is you're not reading carefully enough. So this first sentence here at the top, says the base length, the base width, and the height, so the length, width, and the height of a solid metal cuboid of 35 by 30 by 20. So you've got a cube, like a box. That box gets melted down and then reformed into this shape. So you melt the metal and then you reform it in this point. You melt it and you reform it. What stays constant? All of the dimensions will change when you reform it. What is the one thing that stays constant? The volume. The volume. So what we need to do to begin with is we need to calculate the volume of the cuboid, because it's the same as the volume of the cone. $10.70. Then we look at the formula for a cone. So the volume of a right cone is given by a third pi r squared h. So 1070 is equal to a third pi. Now r is the radius. That's this length here. Do we have any information as to what that is? So the radius is 23 times 23 squared times h. Do we know what that height is? The height is this length here.
So I have a different answer for the volume.
Let me have a look. Did I type them in right? 35, 30, 20. 35. Ooh. 35, 30, 20. To 21,000. Thank you. Did a plus there. So how can we find the height now? N-solve. So let's put this into the calculator. We've got 21000. No, we don't. We've got menu algebra N-solve. 21000 is equal to 1/3 times pi times 23 squared times h, and then we want to solve for the variable h. Make sure we round it correctly. Let me just change my document settings. Document settings. I want float 3. 37.9. Is there a unit? Centimeters. Next, we need to find the size of the angle A. So we need to find the size of this angle here, theta. We've got this length now, which is 37.9 approximately, and we've got this length. So we can just use SOHCAHTOA. This is the opposite. This is the adjacent. So we want TOA. So for B, we want tan of angle VAO is equal to the opposite, 37.9, over the adjacent, 23. So the angle tan to the -1 of that. Yes, Sam? Can we not chit chat? When you use the angle, when you use the length 37.9, use the exact value like this. Use the exact value. If we divide this by 23, and then we need to find the inverse tan of that.
Oh, it's inverse now.
Yeah. I got the wrong answer because I'm in radians, so we just change to degrees. 58.8. So some people got this slightly wrong because they were rounding. If you round the answer, you get it wrong. But also, if you should, some of you are scared about doing 3 significant figures and tend to show about 5 significant figures and hope for the best. But you're more likely to show an error if you do that. So if I just put my document settings now into flow. This was an error I saw. Some people were trying to show more decimal places. So the answer has to follow this pattern. Let's say, for instance, they go back to this, and then let's say they round it to 37.908. 37.908. But then on the calculator, they use that value and then they give lots of decimal places. 37.908 over 23. And then they write down 58.753. 753. So some people, they give several decimal places and hope that this is accurate. And it's actually worse, because if we look to the answer up here, this one should be 58754. I should be rounding up there at that point, not to 3. So I've actually shown a rounding error here by showing more decimal places. If they had done this, where they cut it to this number, calculated it, and then gave 3 significant figures here, they would have hidden the error. You're more likely to hide your error showing 3 significant figures than showing more significant figures. However, the correct technique is to use the exact value. Use this value here like this. Use the full exact value and copy and paste it down, and then you don't get anything wrong. Let's have a look at the last question. Okay, so I'm going to do this one on the calculator fairly quickly.
Especially this was the last one, right? Oh, no.
So here on this calculator, a lot of you actually did this one well.
A lot of you did this one.
You did this one well. This is your favorite topic. This is your favorite topic. A lot of people did this well. Some people, especially those that didn't use the finance solver, didn't do it well. So I thought I'd include this today because there is a few that you can do a little bit better on this. So we need to use the finance solver. Where is that? Finance solver. Howdy's buying a fat? It's 50,000. No, sorry, 500,000. Interest rate is R, compounded monthly in the repayment plan by the bank. A total of 240 monthly payments of 4,500 at the end of each month. What is the value of R? So we've got 240 here for N. We don't know what the interest rate is. The present value is 500,000. He's paying back 4,500. We want the future value to be 0, and then 12 monthly payments. We get 9% interest. So you need.
So when I try to do it, it just gives me error.
Because you quite likely, if you're getting an error on this type of one, it's because you've got both the values as positive. So there has to be a change. Your present value needs to be positive, and your repayments need to be negative to cancel each other out. Your error is because it's never getting to 0. You just keep adding more money in. It will work if they are the other way around, the positive and negative. So this is the way we should do it. So for B, what's happening this time is find the amount he still owes at the bank after 8 years. So what we need to do on this one is we want 8 times 12 as the number of years, months or payments, 96. The interest rate stays the same. The present value starts at 5,000. You're giving the same payments, but we want to know what the future value is. So after 96 payments, it's going to be this much, how much he still owes the bank. So for B, we want N equals 96. We want the interest rate to be 9%. We want the present value to be 500,000. Payments are coming in at a rate of 4,500, and then the payments per year and the compounding periods per year are all 12. This gives us the future value of 395 366.55 336.55. And this is how much he owes. C is most difficult. Find the amount of interest Claudia will have to pay in the first 8 years. So this amount here is how much he still owes the bank. How can we calculate how much of the debt he's paid off? So he started with 500,000. Now it's 395,000. How much of the principal has he paid? How much of the loan has he paid off? We subtract these two numbers. So he's repaid. I'll do it all in one calculation.
500,000.
I'll do it all in one calculation. So we can press the variables button here and we can get some of those values out. So for instance, we can get this value out here. So he started with a present value of this much. I'm just going to add that value to it because it's negative already. The future value. This is how much he's paid off. This is how much he's paid off. How much has he paid? This is how much of the debt he's paid off. How much did he give the bank in this period?
You subtracted by
Omar, try and pay attention instead of using your phone.
Once you subtracted by 500,000.
No, so I've taken the 500,000, I've subtracted what he still owes.
Yeah. So you only have.
So this is how much he's paid off, 104,000. How much does he give the bank each month?
4,500.
4,000. How many months did he do that for?
240.
96. So 4,500 times by 96, that's how much he gave the bank. That's how much he gave the bank. So the difference between these two values is the money that has vanished, the interest. So this value minus this value is the interest. He's paid 327,000 in interest. So he gave the bank so what we want is he gave the bank 4,500 times 96. And then from that we'll subtract how much he's repaid.
Sir, have you ever tried to pour for water?
So we want 4,500 times 96 minus 500,000 minus 395,000. 327,000.
It's not the answer before.
That is the same answer.
It's just rounded.
Yeah.